Welcome to milestone number 4. In the previous milestone, we created our profile view. Now we're going to be focusing on our game view. So the first thing we're going to do is to create a game scene which will be presented within our game view. So we need to go to the edit button, click on the breadcrumbs, click add sprite file. I'm going to call this game scene.swift. Okay, then within game scene, first thing I need to do is to import SpriteKit. Remember, SpriteKit is the library for creating 2D graphics and games. I'm then going to define my class. And I'm going to call my didMove method. By overriding this, this is the first method which is called, a bit like your main method if you're using Java or C or something like that. It's the first method that will get called when the app is created. So I'm going to just remove this so you've got a little bit more room and you can see the wrapping correctly. I'm going to define a frame size. I'm going to use this to set the boundaries for the game. So when the little ball jumps around or the little head jumps around, it'll bounce off the walls. This one as well. And then I'm going to use the frame height as well. From here I can set the physics body to equal sk physics body. I'm going to make this edge loop from and use that frame size. Oh, I just mixed an R in override. Just give me an error. And I also spelt width wrong. So what you get for trying to code while you're talking. Okay, now I'm going to create a label. So this label is going to display our score. So I'm going to set label, sk label node. And I'm also going to create a variable for the score, which will also be used across the entire program. So it's going to sit out of that scope so it can be accessed by all of the other methods. And I'll create a function to define all of the label properties. So first we'll set the font type, or the font family. And again. And I'm going to set the text of it. Now we can't just set this to score because score is an integer, so we need to wrap this as a string. I set the font size to be nice and big. And I'm going to set the initial position of this label using core graphics point. Set it to the mid point of the frame, and about 500 up the y-axis. I can then set the font color so that I can see it. It will be white by default, so let's make it red. And the last thing I need to do, which you need to do with all nodes, is to make sure that you add it to the frame. Okay, so I've defined my function now, but of course I need to call it within my didMove to make sure that when my application loads, this function is also called. Okay, this isn't going to display yet because we haven't presented this scene. So we're going to keep going and we're going to create our ball. So again, we'll create a ball, and our ball in SK Sprite node. with an image profile ball .png. Okay, so I get this, the name of this, if I press add and I go to my assets that I've added in, I can see profile, oops, I can see profile ball .png. I've inserted that from my file, so I went to insert from, and I can see the name of that file name, because we don't have the image literals inside SpriteKit. Okay, so I now have my image. I want to, oops, that's incorrect, image named. I then want to, again, create a function, called create ball, which will set the properties of my ball. So first of all, I'm going to set a name for my ball, which of course will be ball. And then I'm going to set the size. So I'm going to use that ball name later on when we do collision detection. So I'll set, oops, I'm having a hard time spelling width today. I say probably about 80% of the errors that I get from my students are just simple spelling mistakes, and they think their code's broken, but really it's just simple things like spelling width the wrong way. So this is going to define a physics body around my node, which is what we're going to use for our collision. I can then set other physics properties as well. So I'm going to set the friction, and you can play with these settings a little bit when you're testing out your game. My restitution, which if you remember your grade 8 physics, it's how much it's going to bounce. And then of course, as I said before, which you don't need the self, we can just put add child ball. Okay, make sure I spelled restitution correctly. Restitution. Okay, now we have a ball and a label which is displaying. We're going to work on our collision detection. So to do this, we're going to check when we touch on the screen if we've clicked on our ball. So again, we've got these override methods which allow us to do this quite easily. Again, make sure you spell override correctly. So these handle the touch events for us, and then we can just manipulate what we do with the touch location or any other properties that we have within that touch event. So I'm using this touch parameter which is being passed. I'm going to set a new location based on that touch. So I received my touch, so for touch in touches, a simple for loop. I'm using that touch to find the location, so it's one of the properties which I get from a touch event. I can also find out what the touched node is. And this is where we're going to use our ball name that I created previously. So if my front touched node is equal to ball, then I'm going to make it jump off in different directions. So I'm going to set a vector between negative 800, so I want to make it pretty substantial. An 800, so that's my range. My destination y is a random integer between 300 and 800, because I don't want it to bounce downwards, I only want it to go up. Sometimes it will bounce up more, and sometimes it will bounce up less. Okay, then I can apply this vector to my ball. So I can set the velocity of my ball to that vector. Of course, each time I want to add 1 to my score, so we can use that score equals score plus 1, or we can use the shorthand score plus equals 1. It's the exact same thing. And then make sure we update our label. Look at the text property. We're going to set this to our score, just like we did before. The last thing we're going to do within our method, within our game, is to check the Y position, and we're going to pause the game if it goes below a certain touch position. So again, we've got another override function. This function runs every time a frame is refreshed, so it's constantly running. It's basically like our game loop. These are all default methods. You can look in the documentation if you want to look up more. I'm just going to look at the ball location. And if it's less than 200, then I'm going to pause my view. Okay, again, I'm just going to make sure. Oh, terrible with the double R's today. Okay, so we now have our game scene defined. We can't test it yet because we're not presenting anything to our view. So let's go back to our project directory and go to my game view. So click here, or you can go to your tab, and I want to present my game view. So to do this, make sure we've got SpriteKit installed, otherwise you won't be able to create a sprite view. I'm going to create a new scene, which is of type SK scene. So let my scene equal my game scene that we just created. So that refers to our game scene inside here. Scene size equals CG size. My height is 108. Okay, I've used the aspect ratio of an iPhone for this. I'm going to scale this so it fits to whatever size. If you've got a big iPad or a small iPad, or you're doing this on your Mac, it'll also work as well. Set my background color to be white, and this is an opaque view, so I need to return this scene. Okay, and then within our view, we're going to present that scene. So let's have a V stack. Create a sprite view, and in that sprite view it's going to present our scene. We can then change our properties. And I'm going to make sure that it goes all the way to the edges, ignoring safe area. Okay, so now make sure we have these turned off. Hit my run. I've got my profile view. Oh, and I don't have my ball. So that's why it's always important to test. So my ball isn't showing, and your students will make this mistake over and over again, as I just have. We created our function, but we never called it. So make sure we call it. And then we can play our game.